This section is on 5.3 logarithmic functions and graphs. So we're going to continue on from the last section, which was the 5.2 graphing out exponential functions. But this time we're also going to introduce logarithmic functions as well. So exponential functions is similar to what we just did. Remember, this is the y graph right here. So when you have an exponent, like what we did, something like this where it's 2 to the x power, right, or e to the x power, any of that kind of graph, it's going to be very similar to this graph right here. Because anything to the 0 power is 1, so it usually passes through 1 on the y-axis, and so it gives us kind of this graph right there. Now, the logarithmic functions that we're going to introduce today is going to be the inverse. So notice that I still have is that y equals x line right there. So that's our mirror line right there, right? So with the mirror line, this is a reflection, and this becomes the log function. So the log is an upside down L shape. So L for log, if you just remember that. So this is going to be the log. Now, it's most of the time it's going to be written as log, and then there's going to be a base number, a number next to it, which is a big number right here. So this is like a little subscript, and then it equals something, but it can also be written as the inverse, basically, of this right here, because remember, inverse is just basically switching of the variables, right? So that's what this is right here. Also, if you notice, the asymptote. The asymptote is found on the exponent right here. So this is being the x right here is going to be the exponent. So that's your asymptote. So this graph right here never touches the x-axis right here because that's going to be your asymptote right there. Now if you switch the x and y, notice that the y is up on the top right here now. So the y becomes an asymptote for the log. So this graph right here, this is the y-axis right here. So this graph will never touch or cross over the y-axis. It's going to get really, really close to that right there. Okay? So those are some details about the logarithmic and then the difference between that and the exponential. So we're going to do some algebraically, meaning that we're going to switch variables and things like that. So let's work with that one first. So the first example, they gave us the exponential form. So I know it's an exponential form because there's an exponent first of all, and then there's a base number right here. So this is called exponential form. And so we're going to be asked to change the exponential to logarithmic form. So when you change things into logarithmic form, first of all, the word log, right, because log should appear because it's in logarithmetic, okay? So this right here, the 2 is the base number. We call it a base for the exponent right there. So when you change it to logarithmic form, this is still the base number right here. That does not change. So what does that look like? So because we're putting into logarithmic form, the word log has to appear. That 2, which is the base, now becomes a base down here instead, okay? And then the 16 is going to be the big 16 is equal to, and then the x right here. So what just happened? Basically, you're taking this right here, the base right here, you're bringing it over to the other side, and you're making the word log appear with that new base right there. Then the x right here, which was an exponent, which was up on the top, now drops down and becomes a big X right there. Okay, that's it. That's just converting from one form to the other form. We're not solving for right now. That's the conversion part. Okay, let's try another example. So same thing with this one. It's an exponential form because right now we have an exponents and we don't have the word log, so that gives it away that it is not in logarithmic form. So now let's change it to logarithmic form. So the word log should appear. So remember, this is now the base right here. So this is going to become the base of this log as well. So that becomes 10. This right here, we're just copying 0.001 equals, and then the -3 drops down and becomes a big -3. Okay? So I put it both ways so you can see. So this basically is coming over to this side right here. So if it comes over to the other side, this log base 10, right, that's this right here, is going to go here. This gets basically moved over, right, so that's this part right here, and then the -3 comes down and gets dropped down right there, okay? Now let's go the other direction. So let's say we're in the logarithmic form. So obviously because the word log appears, that's why we know it's in logarithmic form. And now let's go into exponential form. So that means the word log right here has to disappear. So remember, when we did this, we moved it from one form to the other form, and you have to cross the equal sign. That's basically an important thing right there. So when you cross the equal sign, it changes right there, okay? So similar to this log base 2, remember, when it comes over, it's going to cross over that equal sign, and this base 2 becomes still a base 2, right? This 5 is going to get pushed up right there and is equal to 32 right there, okay? So if it's, and then if you look at this also exponentially, 2 to the 5th power is like saying 2 times 2 times 2 times 2, right, 5 times, and that should equal to 32. That's how you check your work. So again, let's go from this form to that form right there. So if I'm going from this form, the exponential form to logarithmic form, I'm bringing the 2 over to the other side of the equal sign. This 2 is a base number right here. So if I'm putting it to logarithmic form, the word log has to appear with the base 2, right? That's this part right here. The 32 gets moved over, so which is this part right here, and the 5 comes down from becoming an exponent. So you can go both directions on this, okay? One more example, and now this I just put a general equation. I didn't even put numbers, so you can see that move right there. So again, we're going from logarithmic form to exponential form. So this right here is the base part right here. So the base t, that's base t right here. The x becomes an exponent because we're crossing this over to the other side of the equal sign right there. And then the m just stays by itself right there. Okay, and if you change the form from exponential to logarithmic form, again, this base t, if I bring it over to the other side, in logarithmic form, the word log appears, then this becomes a base, which is this part right here. The m gets moved over, and the 5, oops, not 5, it should be, what is that? X, right? Okay, so the x should come down and then becomes a big X right there. Okay, I looked at the wrong problem right there. Okay, so now that's one form that you'll be doing today. The other one is going to be now calculating. So this right here is the calculation. Now there's a couple of things we also have to introduce. This right here should be on your scientific calculator is the word log and also ln and e, because we're going to do some of those calculations. Now log can be put in the calculator if it is a base 10. Now let's go over that. So if the base right here is not written right here, and you have this big 25 right here, this is automatically a base 10 right here, okay? So if it's not written, it's base 10. If it's written, then it's whatever the base is. So if you notice, it's going to say log, and then there's a little subscript, either base 2 or base 5 or something like that. But if it's not written, it's automatically a base 10. It's kind of like when x is by itself. We know the power to x will be a 1, right? Same thing with the square root. We normally don't put a 2 for the square root, but we already know it's a 2. So it's the same idea with the log. The base right there, if it's not written, it's automatically a 10. Okay? So when you're doing this calculation, if it's a base 10, you can actually put in the calculator. But if it's not a base 10, you have to change the form. Okay? So let me show you also when you put in the calculator how that looks like. So the word log is going to appear right there. So just like that right there. Now, the calculator, it's already a base 10. So the calculation only happens if it's a base 10. If it's a base 5 or anything else, you have to change the format. So that's why we have to talk about that, okay? So now this is base 10, so it says 25 right there. So all I have to do is now enter in 25 right there, and then that's going to be your answer right there, okay? So it's 1.397. So I'm going to put equals, so x is equal to 1.397. Now try to take more decimals as possible. So I'm going to take about 4 or 5. So let's see, 794. So we'll go 794. The more you take on that decimals, and when you convert it to the other way, the better it becomes. The less you take, it's going to not become as accurate. Okay, now that's going to be the answer. Now let's say it was not a base 10 right there, and it was a different base, and I had to change the format. So let me show you how that works. So whenever you're doing the calculations, and let's say you it's a base, a different number right here, what you're going to have to do is put it into exponential form. So put this into exponential form, putting it into exponential, then we'll change this to, so this is base 10, comes over, crosses over the equal sign, it becomes a base 10 right there, to the x right there, right, is equal to 25 right there, okay? So that doesn't change right there. So again, you can always check your work on that by bringing the 10 over on the other side. 10 becomes a log base 10, right, which is that. 25 gets moved over, which is this, and then x drops down from becoming an exponent, okay? Now, when you get to this format right here, the exponential form, what you're going to do is you're going to go log on both sides of the equal sign, so log on both sides of the equal sign. And when you do this log on both sides of the equal sign, the exponent actually can come down from becoming an exponent. So this is a property we'll learn for the next lesson. But I'm going to kind of give you a heads up on this because there is a formula, but once I show the formula, it gets a little confusing if you don't know what you're doing. So I'd rather show the property of how to do this, so then we also do the next section, the property makes sense as well. So you bring the x down, and then you're going to have is log 10. So the word log, it should always have a number right there. Okay, so if it doesn't have a number, then that's wrong. So you know on this one right here, you can't put 25 and then log because it's log 25. You have to put a log and a number right there. Okay, so then from here, we're solving for x. To solve for x, this is x times the log base 10 or log 10. So to solve for this, you just basically have to divide it both sides by log 10. So log 10, log 10. So x is equal to the log of 25 divided by log 10. So this now becomes the calculated portion of it. So this you put in the calculator. Same thing what we just did right now. So let's see, log 10 divided by log, oops, the other way, 25. 25 divided by log 10. So log 10, and then press enter, and that's going to give us a 1.39794, which actually was the same answer as this right here. Okay, so again, that's that only works if, or actually for all of them, it does work because as we show this part right here. So if it's log base 10, you can just put it into calculator, straight into this part right here into the calculator. If it's not base 10, this is the changing of the base right here. You have to put it into this format right here and then solve for it to solve for what the x is. Okay, so that's one thing you'll do. Then the other thing we'll do is now change and introduce the e of x and also ln. So the last one that we just did, if you remember, it was like e of x, the inverse of that turns into log, right? And then this right here, I'm sorry, the exponential talks and turns into log, and then e in this case turns into ln. Now, the question then usually is, what is the difference between this e and this other stuff? Remember, let me show that graphically. It's exactly the same. Remember on the e last week we talked about this. This part right here, the e was this graph, is same graph, because if e to the 0 power is still 1 right there, so that was the we part of it right here, okay? The inverse of e is this right here, which is the ln as well. So log and ln are exactly the same, and then e, and then to the something power, whether it be 2 to the x or 5 to the x, any exponent form right here, that's this graph right here as well, okay? So the difference then becomes is that log is base 10 and e is not base 10. It's going to be base a different number right there, okay? So the same thing with this one. They're going to ask you to do some calculations on the calculator. So if it's like e to the 4th power, or actually let me convert it to. So similar to that log and e thing, we're going to go ahead and change it. So this right here is called exponential form because, again, you see exponents. So since this is exponent right here, it's an exponential form. If I change e, this e is a base right here, still the same thing, and I bring it to the other side of the equal sign, what happens to e is it actually changes its identity to an ln instead. So that changes right there, okay? The y is still the same. It gets pushed over to the side, and the x comes down from becoming an exponent to a regular x right there. The only difference on this is that e does not have a base number when it turns into this. Remember, the log had a base number, but this one does not have a base number. So that's the only difference on that part. Okay. Now, the calculation. The calculation is the e right there, e to the fourth, is going to be exactly the same on your calculator. So you should have an e button, e, something like this. And if you put in 4 and then you press enter, it's going to give us a number. Okay, so in this case, e to the fourth is 54 point, let me see, 59815. Okay, 59815. Okay, so now if I want to change the form from where it is right now, which is the exponential form, to an ln, so that becomes exactly the same thing. So this right here is the base right here. If I bring it to the other side of the equal sign, e turns into an ln identity, so it becomes ln. Then I would write all of this right here. So ln of 54.5915 is equal to, and then the 4 drops down from becoming an exponent and then becomes a big number right here. Now you can also test or check your number right here as well. So there's also an ln button on your calculator. So if you go ln, let's put that side by side so you can kind of see that right there. So ln, if you put in 54.5915, it should then equal to 4. Now obviously this number right here, 3.9998, is going to be really, really close to 4, because the more we carry in this number right here, when we put that in the calculator, the more we're going to get closer to this to be a 4. So you can see the number is going to be off a little bit just because of the rounding. So if you go 54.5 or 6 or something like that, you're probably going to get less of that accuracy. So try to carry as much as possible the number if you have to do the calculation part of it. Okay? So that's one thing you're going to do also on a MyMathLab. And then the last one is not necessarily, well, I think there is a graphing one, but also they're asking you to do some of the graphing and also identifying it, kind of what we just did last time. So the identifying part of it. So when you have the word ln or the log right here, a number in front of it, which we call a coefficient right there, the coefficient of ln or log is always going to give us the width of the graph right there. Okay, it's not going to change anything but how wide or how tall or how skinny that graph is. That's that part right there. Now, inside this part, which then after the word ln, there's going to be usually a parentheses with something in there, or log, and then there's going to be something in there, right, which we've done so far. This right here is going to shift it to the left or to the right. Okay, so that's going to be similar to what we just did on the exponent. We talked about the exponent last week. So the exponent, if it is positive, remember you go the opposite sign. If it's negative, then you go to the opposite sign. So same idea right here on the shifting left and right, you just go opposite sign. So if it's x plus, you're going to go to the left. If it's x minus, you're going to go to the right instead. Okay. I believe one of the questions or two of the questions is asking us the vertical asymptote. So vertical asymptote is also found from inside this part right here. So once we set that equal to x right there, you're going to find out what is the vertical asymptote. And then the last part, similar to what we just did on the e and also the base or exponential graph, if it's a plus and minus and then some number on the outside of this, and that's the bigger number right here, this still does the up and down shift on this part right here. Okay, so let's go to the graph then. So you're going to have a graph that's similar to this right here. This is the graph, and then the belly. Remember we talked about this being the belly right here. So the belly right here usually is at 1. So at 1 is the belly. So once we get that belly, then from there we're going to shift it either to the left or to the right of this right here, or up and then down from there. Okay, so similar to what we just did. So if it says like +5, you're going to take this L shape right here and basically take this belly right here, go up 5 spaces, and then you're good. But if it's inside the parentheses, depending on the parentheses of that, if it's either positive or negative, then you're going to take this belly, either move it to the left or move it to the right of that graph right there. Okay? All right, then let's go ahead and try the My Math Lab.